So in the previous video we were seeing what is meaning of polynomial, what is mean by value of polynomial and zero of polynomial. Then we tried to plot linear equation in a Cartesian plane and we got a straight line. Then we were applying degree 2 equations in the Cartesian plane and we got the U-shaped parabola. Now we can see some more examples. For this second degree polynomial, number of zeros is only 1. But it is possible to get more than 1 zero. We can see in this example x square minus 3x minus 4. So we'll take it at y is equal to x square minus 3x minus 4, and when we draw the x and y values, we can consider from minus 3, minus 3, minus 2, minus 1, 0, 1, 2 and 3. So what will happen if we put x is equal to minus 3 square will be 9, and minus 3 into minus 3 will be minus 6, minus 4 is minus 10. So 9 minus 10, that will be minus 1. What happens if we substitute minus 2 plus 4 plus, when we substitute minus 3 we will get sorry about that. So when we substitute minus 3 we are getting minus 3 the whole square and minus 3 into minus 3 and minus 4, which is equal to 9 plus 6 minus 4, which is 15. So y is 15. And for minus 2 we are getting minus 2 whole square minus of 3 into minus 2 and minus 4. This is equal to 4 plus 6 minus 4, which is 6. And when we substitute minus 1 we are getting plus 1 plus 3, which is plus 4, and minus 4, which is 0. And when we substitute 0, 0, 0, and we are getting minus 4. And what happens when we substitute 1? So 1 minus 3 minus 4, which is minus 4 minus 3 will become minus 7 plus 1, so minus 6. And what happens for 2? When we substitute 2 we get 2 square, which is 4 minus 3 2s are 6 minus 4, which is minus 6. Yeah, minus 6, and we substitute 1 minus 3 minus 4, which is minus 7. Yes, and when we substitute 3 we are getting 3 square is 9 minus 3 3s are 9 minus 4, we are getting minus 4. So now we can plot this in the graph. Minus 3 and plus 15 will be way above, minus 2 and 6, minus 1 and y is 0, and we are having 0 and minus 4, 1 and minus 6, 2 and minus 6, 3 and minus 4. So we can find for more values here. Let's find for 4 and yes, for 4 and 5 we can find out. So what is the value? What value for 3 was -4, and when we substitute 4 we will get 4 square minus 4 into 3 is 12 minus 4. So we are getting 16 minus 16, which is 0. And when we substitute 5 we get 25 minus 15 minus 4, which is 6. So at 4 it is 0, and at 5 it is y is 6. We can join all these points now. We got our parabola, a U shape. Yes, so it will be from here. Yeah. So this is our U shape, and it is touching the x-axis on 2 points. The first point is -1, 0, and the second point is 4, 0. So x is equal to -1 and x is equal to 4. These are the two roots of this polynomial. So previously we saw an example for degree 2 equation with only 1 0. Now we saw example with 2 0. A third example now, which is y equal to x square minus 3x plus 4. When we plot this graph, the graph will look like this. It will never touch the x-axis. So this will have no 0 or no roots. Is it always necessary that the parabola is facing upwards? No, we can consider this equation, and if we plot the graph for it, it will look like this. Wait a second. So the U shape will be facing downwards. So it doesn't matter if the parabola is like this or it's like this. Both are called parabolas only. So now we can see what will happen for degree 3 polynomials in Cartesian plane. So degree 3 polynomial will have S shape, and they can have at most 3 zeros. So we have an example which is y is equal to x cube, and the graph will look something like this. So S shape, you can see there are two bends, and it is having only 1 0. Y is equal to x cube has only 1 0. X cube, the polynomial x cube has 1 0. There is a possibility for the S shape to be formed like this, and in this case the number of zeros is 1, 2 and 3. So 3 zeros is also possible. What happens when the S shape is formed like this? So there are only two zeros here, 1 and 2. So the graph of a degree 3 polynomial, or it is also known as cubic polynomial, could be like this with two zeros, or it could be like this with 3 zeros, and it can also be with one single zero, but all of them will have the S shape. So far we have seen if it is degree 0, then it is called constant polynomial. An example for constant polynomial we saw 6. When degree is 1, it's called a linear polynomial. An example we saw when degree is 2, it's called quadratic polynomial. Example will be and degree 3 is called a cubic polynomial. An example will be x cube plus 3x square minus 2x plus 4. So number of zeros for all these things is, this has no zero since degree is 0, and here since degree is 1 it has 1 0. Here degree is 2, so it has at most 2 zeros. That is maximum it can have 2 zeros. A degree 2 polynomial may have no zeros also. We have seen an example for it. This is a degree 2 polynomial with no zero. It never touches the x-axis. And for degree 3 we have at most, that is maximum, it can have 3 zeros. So we now know what is the meaning of roots of a polynomial or zero of a polynomial. Now we can see a relation between the roots and the coefficient of a polynomial in the case of quadratic polynomial. So a quadratic polynomial can be expressed in the general form as ax square plus bx plus c. Okay, so this is the general form of a quadratic polynomial. The degree is 2 and it has two coefficients and a constant. Now there is a relation between the zeros and these coefficients a, b and c. So let the zeros be, since it is a quadratic polynomial, it is possible to have 2 zeros. So we can take the zeros as alpha and beta. Now the relation between the coefficients, that is a, b and c, and alpha beta will be the sum of the zeros is equal to minus coefficient of x by coefficient of x square. This is the first relation, and the second relation is the product of the zeros will be equal to the constant divided by the coefficient of x square. We can expand it like this: sum of zeros is equal to minus coefficient coefficient of x, or linear term, we can call x as linear term, divided by coefficient of x square. The same way, product of zeros is equal to constant term by coefficient of x square. Now let us check this relation with some examples. So we can consider the example. So this is our polynomial that I have chosen for example. So in this polynomial, first let us try to find out the roots of these polynomials. Let us try to find out alpha and beta. How can we find alpha and beta for this? This can be written as 2x square plus let's try a different example which is a little bit more simpler. X square plus 2x plus 1. So we can consider this polynomial. So we can write this polynomial as x square plus x plus 1. This polynomial can be written like this. Just this 2x is splitted into x and x. Now we can take x common from both of these terms. We will get x into x plus 1 plus we are having 1 into x plus 1. This can be written as x plus 1 into x plus 1. So here either x is equal to minus 1 or x is equal to minus 1. Alpha we can take as minus 1 and beta also let us consider as minus 1. So we can check for alpha plus beta which is equal to minus 1 which is equal to minus 2. And the relation says alpha plus beta should be equal to minus b by a or minus coefficient of x by coefficient of x square. So minus b by a in this polynomial will be minus of b is minus of 2 divided by a is 1 here. So minus 2 by 1 which is equal to minus 2. Hence we have proved alpha plus beta is equal to minus b by a. Alpha plus beta, we substitute alpha and beta values, we got minus 2. Then we substituted minus b by a values also, we got minus 2. So this relation we have proved. One more relation is there which is alpha beta is equal to c by a. So for alpha and beta, if we multiply minus 1 and minus 1, we will get 1. And what is c by a? In this polynomial, the constant is 1 and a, the coefficient of x square is also 1. C by a is also 1. So alpha beta is equal to c by a. So we have a relation for any quadratic polynomial ax square plus bx plus c with roots alpha and beta. We have roots alpha and beta and a quadratic polynomial like this. We can say the sum of the roots will be minus b by a and product will be c by a. This is the relation between the zeros and coefficients of a quadratic polynomial. Now with this relation we can write a polynomial's general form as this. A polynomial can be written like x square minus alpha plus beta into x plus alpha beta, where alpha and beta are roots. So if we know the sum of in order to find the sum of the zeros and product of the zeros, if we have a known polynomial we can write it based on this formula minus b by a and c by a. And if we do not have the polynomial but we know the roots, Then we can add the roots, we can multiply the roots and substitute the value, and we can build the polynomial by ourselves. So these formulas are very useful. So if you have any doubts regarding this chapter, feel free to discuss in the comment section. We'll try to answer as many questions as possible. So thank you. I'll see you in the next video.